Assalamu alaikum. So today we are going to study about the pathogenesis of atherosclerosis. The pathogenesis behind the formation of atherosclerotic plaque or atherosclerosis. We have already discussed the definition, the etiology, both the modifiable and non-modifiable causes of the atherosclerosis. And today we are going to study about the pathogenesis, that how does the atherosclerotic plaque develops. So there are many theories that explain the formation of atherosclerotic plaque, but the most accepted theory nowadays is the response to injury hypothesis. So what is response to injury hypothesis? What it states? So this states that atherosclerosis is due to the chronic inflammatory response of the arterial wall, usually the tunica intima, to the endothelial injury. It is a chronic inflammatory response of the arterial wall to the endothelial injury. So now let's discuss the steps involved in the pathogenesis or the response to injury hypothesis. The first one is the endothelial injury. So the endothelial injury and the resulting endothelial dysfunction is the initial and the triggering event in the development of lesions of atherosclerosis. It is the first and the initial triggering event in the development of the lesions of atherosclerosis. So the most common causes of this endothelial injury in case of atherosclerosis may be the hemodynamic stress from the hypertension or simply hypertension. So how this hemodynamic stress from the hypertension causes the endothelial injury? So usually the normal or the non-turbulent laminar flow leads to the induction of the endothelial genes which protects against the atherosclerosis. For example, this is the blood vessels. So the non-turbulent blood flow induce these endothelial cells to produce genes which produce such products, that these products prevent these blood vessels from developing an atherosclerotic plaque or the atheroma. So this is the first reason or the first cause, the most common cause of endothelial injury. The second one is the chronic dyslipidemia. So how this chronic dyslipidemia cause the endothelial injury, so we will discuss in this slide. It is a complex slide, but I will try to make it a simpler positive. So it causes the endothelial injury by two reasons. The first one, that this chronic dyslipidemia impairs the endothelial cells function by increasing the local oxygen pre-radical production. This chronic dyslipidemia increases the pre-radical production which accelerate the nitric oxide. This is the nitric oxide decay or the decomposition, and thus decreasing its vasodilatory activity. So decreasing the vasodilatory activity can make the blood vessels at more risk for the endothelial cell injury. The first one is simply by decreasing the vasodilator activity of the nitric oxide by producing pre-radical production. The second reason, that this chronic dyslipidemia, the plasma LDL is increased, and this plasma LDL, low density lipoprotein, enters into the intima and undergo oxidation. For example, this is the blood vessel. So if the LDL is increased, they passes through the endothelial cells into the intima, and here it is oxidized. Here in the intima it is oxidized, and this oxidized form in the intima performs the following important functions on the monocytes. It is the pus cells and the endothelium. First we will discuss the important functions or the effects of this oxidized LDL on the monocytes. So what this do? This oxidized LDL cause the monocytes to proliferate and immobilize these monocytes. They attract cause the monocytes to proliferate and in turn immobilize these monocytes at the site of injury. And when this oxidized LDL is taken up by these monocytes by the help of the scavenger receptors present on the membrane of monocytes, it transports this monocyte into lipid-laden sperm cells. And the death of these sperm cells by the apoptosis release the lipid which form the lipid core of the plaque. So the lipid core of the plaque is mainly produced by the apoptosis of these lipid-laden sperm cells produced from the monocytes by the uptaking of the oxidized LDL. The second one and the most important one is this oxidized LDL is cytotoxic to the endothelium. This oxidized LDL is cytotoxic to the endothelium, and producing a cytotoxic activity, this can damage the endothelium and thus it causes the injury to the endothelium by the chronic dyslipidemia. So these are the some functions of the chronic dyslipidemia which help in the formation of atherosclerotic plaque. Now the second step, as we have already discussed the first step, which is the endothelial injury. This is the first step. So now we are going to study the second step, which is the intimal smooth muscle cells proliferations and the production of the extracellular matrix. So how this smooth muscle proliferate and produce the extracellular matrix. So when there is endothelial injury, as we have already discussed, the most common causes are what? Can you guess? The first one is the hypertension, hemodynamic stress from the hypertension, and the second one is the chronic dyslipidemia. These are the two most common causes of endothelial injury. When it is injured, it causes the adherence, aggregation, and the platelet. It causes the adherence, aggregation of platelets, and also causes the platelet release reaction at the site of the exposed subendothelial connective tissue after the endothelial cell injury. The other one, it also causes the recruitment of the inflammatory cells like monocytes and macrophages. They are also recruited or attracted by the oxidized LDL. So it is the second stimulus for the recruitment of the monocyte and macrophages. This is the second effect caused by the endothelial injury. The first one is the adherence, aggregation, and the platelet release reaction at the site of the injury. The second one is the recruitment of the inflammatory cells to the site of injury. And the third one is that increase the permeability of the endothelial cells for the macromolecules like the LDL. So they can easily enter into the intima. These all effects in turn cause the proliferations of the intimal smooth muscle cells and the production of the extracellular matrix, and they are stimulated by the various cytokines like interleukin 1, tissue necrotic factor alpha released from these invading monocytes and macrophages and by the activated platelets at the site of endothelial injury. So what this platelet adherence and what is the function of these platelets, monocytes and macrophages? They in turn produce the cytokines like interleukin 1 and tissue necrosis factor, and these in turn causes the proliferations of the intimal smooth muscles and the production of the extracellular matrix, so in turn increase the size or helps in the formation of the atherosclerotic plaque. As these are the components of the atherosclerotic plaques, as we will discuss in the morphology of the plaque. Now the third step, the first one is the endothelial injury. Keep in mind the second one is the intimal smooth muscle cell proliferations and the production of the extracellular matrix, and these extracellular matrix include the collagen, etc., elastin, now all of these components like the low density lipoproteins or the oxidized LDL in the intima, the foam cells formed from the macrophages or monocytes containing oxidized LDL, and smooth muscle cells, and the extracellular cells or the extracellular matrix cells or the extracellular matrix itself, they all help in the formation of this atherosclerotic plaque. All of these are the component of the atherosclerotic plaque which we will discuss in the morphology in detail. Now the third step, we've already discussed the first step, endothelial injury, second step, intimal cell proliferation and the extracellular matrix production, and the third step is the thrombosis. And this occurs due to the small platelet aggregation at the site and the fibrin and cells attachment from the blood, so that the thrombus become a part of this atheromatous plaque. They occur due to this platelet aggregation at the site of the endothelial injury, as we have already discussed. And after this, the fibrins and cells from the blood attach to this platelet aggregates, and this thrombus then becomes the part of the atheromatous plaque. Now what this thrombus do? This thrombus stabilizes the plaque. So the larger the thrombus, the more the plaque will be stabilized. As you can see, this is the diagrammatic representation of all of the components of the stages of the pathogenesis of atherosclerotic plaque formation. The first one is the endothelial injury. This is the media. Here you can see the elastic lamina. This is the blood vessels, and these are the endothelial. And here you can see the endothelial injury, also known as the denuded endothelial lining. And this is the subendothelial connective tissue. After this endothelial injury, what occurs? There are platelets, aggregates, blood, macrophages are attracted to a site of injury. Here you can see the POM cells formed from these macrophages containing oxidized LDL, and also you can see the small number of intimal smooth muscle cells, although they have not yet started the proliferations. The third step is that these smooth muscle cells start proliferating. As you can see, a lot of smooth muscle cells here. Also the POM cells increase in size. Also you can see the extracellular cholesterol, which are not oxidized or which are not taken up by the monocyte or macrophages. They are also present in the atherosclerotic plaque. So this is the summary of all of the pathogenesis of the formation of atherosclerotic plaque.